It's video notes 4.1. We got 6 things to do today, and hopefully you can figure out why I'm playing this song. Okay, so here we go. Alright, make sure you read these chapter sections 7.1 and 7.2. Alright, check out some practice prompts, see if you can do them. Alright, here we go. Bonding. What helps us do bonding? Well, we have to look at electronegativity. Alright, so again, here's the definition. I think you got that down, but I put it in anyway. Alright, so if an atom is very electronegative, it's going to pull the electrons all the way off of another atom. So far we talked about sharing, but now we're talking about not sharing, but actually transferring electrons. So which atoms are going to transfer? Well, the non-metals are more electronegative, so than the metals are, so the metals are going to lose their electrons to the non-metals. So where are they transferred? From metal to non-metal. The electronegative metals, non-metals, gain electrons from the metals. Okay, so what forms from that? It's called an ionic bond. An ionic bond is held together because the positive cations are attracted to the negative anions, and those are electrostatic forces of oppositely charged particles. Oh, train's coming, to hear that? Anyway, so what happens? Well, most ionic compounds have high melting points. All right, generally they're hard, brittle materials. They are good electrical and thermal insulators, meaning they don't conduct electricity when they're solids. Okay, thermal and electrical insulators means heat doesn't really go through them really well, and electricity doesn't go through them when they're solid. Keyword, when they're solid. No conducting when they're solid. But if you melt them or dissolve them in water, they will conduct electricity, and that's one key to know when you're talking about an ionic compound. What happens? A metal and a non-metal are bonded together, or a positive ion and a negative ion are bonded together. All right. The reason that it happens is because there's a big end. That doesn't mean there's a big end. It means there's a big electronegativity difference. Electrons are transferred. A lot of ionic compounds do dissolve in water. Okay, what test can we do to see if the substance is ionically bonded? Well, we could bring down the hammer. You can't touch this, bring down the hammer. All right, so you hit an ionic compound with a hammer and you mess up its structure. So here's its structure: positive ions, negative ion, positive, negative, positive, negative, positive, negative. The attraction between those ions holds it together. You use a hammer, you shift ions next to each other that are the same charge, and they break right along those lines. They shatter or are very brittle because you're forcing positive ions next to positive, negative next to negative when you bring down the hammer. So just remember, can't touch this. All right. What happens if you take an ionic compound and put it into water? Okay. Well, when it's a solid, those ions are locked in place. Let me show you what I mean. Solid, locked in place, can't move, locked in place. But if you put it into a liquid, if you put it into water, then those ions get dissolved, okay? And you have positive ions and negative ions in water, all right? And so then the positive ions can flow and the negative ions can flow, and that causes charge to move, all right? So ionic compounds, so pure water does not conduct electricity, all right? Solid ionic compounds do not conduct electricity because those ions are locked in place. But when ionic compounds are dissolved in water, those ions can move and cause charge to flow, and I have an idea that they can conduct electricity. All right, so why do atoms bond at all? It's because of stability. All right, so this atom has 1 electron in its highest energy level. This atom has 7 electrons in its highest energy level. What would be more stable? If this one goes there, then this one has 8 in its outer energy level, and that one has 8. Sodium transferred to chlorine, you get a sodium ion, cation, chloride ion, ionic bond. Okay, bonds form because of stability. Okay, what happens when lithium and fluorine meet? Well, lithium has 1 outer electron, fluorine has 7 outer electrons. If this goes there, then lithium now has a full first energy level, and fluorine has a full second energy level, and everybody's happy, and these positive and negative ions attract each other. So why don't noble gases react? Well, look at this is the energy diagram electron configuration for neon. Full outer shell. Here's what fluorine has. Sort of almost full outer shell, just needs 1 more. All right, so this atom's going to bond to get a full shell. Why are they noble? They don't need us. They don't need us. They're noble. Oh, great, horrible accent. All right. So, what do we call the ions that form? Well, here are some rules you should put in your notes. Cations are named the same as the element, but with the word ion. So, if you see the word potassium, but then the word ion next to it, we're talking about the potassium ion, positive 1 charge. Magnesium ion means it used to be a magnesium atom, but it lost 2 electrons, and now it's a magnesium ion. Anions are named like the element, but the ending of the name changes to IDE. So what element was this? This used to be chlorine, but now it's a negative ion, so it's chloride. This used to be nitrogen, but now it's a negative ion, and it's nitrite. Okay, so change the ending of the anion to IDE, change the name of the metal ion to the word ion. All right, what kind of elements form ionic bonds? Metals and nonmetals form the ionic bonds. So use the periodic table to figure out the charge. Remember, it's +1, +2. Okay, 0, -1, -2, -3. Okay, and then we have +3 over there. We're not going to worry about those ones. So, what ion will sulfur form? Well, sulfur is right about there. So, sulfur is going to form a -2 ion. It's going to be called sulfide. All right, lithium. Lithium is right here. Lithium is going to form a +1 ion. So, it's going to be a lithium ion. Lithium ion. Okay, ion. Bromine. Bromine is right about here. All right, bromine's a halogen, and so it's going to form a -1 ion, and it's going to be called bromide. Bromide. All right, metals and nonmetals work together to form ionic bonds. Hey, there are some what I call always metals. Always metals will be metals that will form the same ion no matter what kind of bond they're making, okay? They will always form the same charged ion. Group 1, right here, +1 ion, always. Group 2, right here, alkaline earth metals, +2 ion, always. Those are always the same charge. Aluminum is in group 3. It's a +3 ion. Zinc is a +2 ion. Silver is a +1 ion. I call them the always metals. +1, +2, everything in that group. +3 for aluminum, +2 for zinc, and +1 for silver. Okay, so aluminum will always form a +3 ion. Al +3, 1 is an ion. Zinc is a +2, silver is a +1. They are always the same charge when they form ionic compounds because they always lose the same number of outer electrons. Hey, look, there's a ton of other metals. Okay, these are other metals, these are other metals, these are other metals. So they are not always the same charge. We'll learn what happens to them later. All right, so monatomic ions are what we just talked about, ions that come from the periodic table. But what about polyatomic ions? Polyatomic ions are many atoms with a charge, okay? So you have to know the names of the formulas of and the charge of the polyatomic ions. These you can't look at a periodic table and get. You got to look in your brain and get them. So if I say sulfite, you say SO3 -2. Sulfite. I think I heard you say it. Cyanide. I say cyanide. You say Cn-1. Cyanide. Cn-1. Cyanide. Cn-1. If I say nitrite, NO2 -1. Chlorite. ClO2 -1. Okay. Remember our little mnemonic. See, oh, look at that clown. Never making CP pies. All right. So let's talk a little bit more about polyatomic ions. It's many atoms with a charge. Is this a polyatomic ion? Well, lots of atoms has a charge. Yes. Polyatomic ion. Polyatomic ion. Okay, is this a polyatomic? Look, more than one atom, charge, yes, polyatomic ion. Is this a polyatomic ion? More than one atom, no charge, so this is not. What is this? Well, look, it's 2 nonmetals, covalent compound. All right. Hey, what about this? All right, one atom with the charge, but only one atom, so this is not a polyatomic. It's a, this is a monatomic single atom ion. Okay, all right, here's the rule for polyatomic ions. I ate more than I ate. What does that mean? Look, it's chlorate. All right, ClO3 -, memorize it. So then what's chlorite? Well, 8 has one more oxygen. All right, so it's ClO2 -1 for chlorite, one less oxygen, 8 an extra oxygen for the 8. Nitrate, memorize it, NO3 -. Right? Nitrite has to be NO2 because one oxygen less. Hey Java, save some chicken for us. All right, ion versus not an ion. Ions have charges. Don't you forget it. Anions are negative and they come from nonmetals, or polyatomic anions are negative. Cations are positive because they come from metals and they lose their electrons. All right, distinguish between elements and compounds. All right, so an element is only one type of atom. Elements don't have charge. Compound is two or more types of atoms bonded together. No charge. Okay, no charge. No charge on these. All right. Ions are atoms or groups of atoms with a charge. So here's some examples. H2, what is it? Element. Fe, what is it? Element. FeO, all right, two atoms, no charge. This must be a compound. Okay. CO3 negative 2, a couple of atoms charged. This is an ion. What kind? Polyatomic. CO2, couple of atoms, no charge. This is a compound. All right. What about this? CaCO3, that's a heck of a lot of atoms. I don't see any charges, so this is a compound. Fe plus 3, wait a second, it has a charge, it's an ion. N2, element. It's two atoms of N bonded together. Okay. Ionic compounds. How do we know it's an ionic compound? We look for a metal or the polyatomic ion NH4+. It's the first part of our compound. Then, after you look for that part of the compound, you look for the other part and make sure it's either a non-metal or a polyatomic anion. All right, so what do we do here? Okay, it's a compound. What kind? Metal, non-metal. This is an ionic compound. Okay. Hey, it's a compound. Metal, polyatomic ion. This is an ionic compound. Ionic compound. All right. Hey, what's this? Oh, a non-metal and another non-metal. No charges on it. This is a covalent compound. All right. What's that? Wow. That's our NH4+. That's the beginning of this thing. But I know overall this has no charge, which makes it a compound. What kind? Ionic. Because it's made up of ions. Non-metal, non-metal, covalent compound. All right. Non-metal, non-metal. Charge. This is a polyatomic ion. All right. So our newest thing are ionic compounds. There's 3 of them on here. These are all ionic compounds. Next, hey, wait. This is the last slide before we want to make sure that you're doing everything, all right? Chapter 7 is going to help you, all right? It's hammer time. Make sure you know these notes, all right? I'm going to do a little review with you. Review, okay? Metal and non-metal make ionic, all right? Or you got polyatomic ion for that and a polyatomic ion for that, all right? The other thing you should look for, all right, is the props. Give ionic compounds their props, all right? You must know their props. Describe their props. Okay, solid. High melting point, all right? Not conducting when they're solid, but conduct when they dissolve, all right? They are not malleable. They are brittle. Alright, make sure you can look at the periodic table and know the ions. So anyway, peace out. It's hammer time.